The first step in the shaft design is going to be the estimate of the properties for the steel that we're going to use for that shaft. So according to the shaft we have and the amount of the power exerted on it and the RPM value or the angular velocity we're going to have, we're required to have a steel for this procedure. Usually the steel can be classified into a different types, and each of them is going to have different properties. So if you're going to check the appendix at the end of the textbook, you'll find a list of the available steel type. This is an example of the appendix number 3, where we have the desired properties of the carbon and alloy steels. In this table, you'll find what will be the SAE number for the steel type and the condition. And finally, we're going to have the column for the tensile strength and yield strength. Also, we can find the ductility and the brilliant hardness number. Now we'll assume the design procedure. So the first step is going to be the estimate of the properties for the steel for that shaft. So it is known that the shaft will be machined from the SAE 1144 or QT 1000 steel. Thus, several factors can be determined, which are namely going to be the SY and the SU. The SY is yield stress, and the SU is the ultimate tensile stress. And we can find that either from the tables or from the figure A42 in the textbook. Now we're using the figure A42, which is the properties of the heat-treated SAE 1144 oil-quenched and tempered steel. So the temperature given to us was 1000 Fahrenheit. So if we go to the x-axis, we will find the 1000. We sketch a line that's going to intersect with the tensile strength and the yield point line, red and the blue. From there, we can find the value for the SU and the SY, where the SU is going to be the tensile strength and the SY is going to be the yield stress. And I'm going to use these values for my further calculations. Finding the ultimate strength or the tensile strength is not going to be enough to complete my solution. Accordingly, we need to use the value for the tensile strength found earlier, or the SU value at the x-axis, to find the endurance limit or the SN value. To do that, we simply going to sketch a line where the value of the SU is 810, and then I will intersect with the machined or the cold drawn, because the shaft definitely is going to be machined or cold drawn. It's not only going to be ground, it's not only going to be polished, and it's not going to be just hot rolled, and it's not going to be forged alone. So what you can see here that the process of making the parts by using the deformation and machining processes. So we're usually going to do the forging, then we're going to do the hot rolling, then we're going to do the machine or the cold drawing, then we're going to do the grounding, then we're going to do the polishing. So we're going to consider that my part is going to be definitely just machined or the cold drawn, and we can find at the intersection that the value for the SN or the endurance limit SN is going to be equal to 289.59 megapascal. We know that we cannot use the SN value directly, so we need to find the modified value for the SN. Now we need to find the different parameters, which are going to be the CR, the CS, the CM, and the CST, which are the factor for the reliability, the size factor, the material factor, and we can find all these values from the figure 5.9 and the tables 5.1 and the 5.2, and the design factor we're going to use in this example is going to be equal to 2. So from the data above, we can find the modified endurance strength value, which can be computed by multiplying the the endurance strength that we found earlier by the multiple factors that we just found on the tables. And plus, we are going to find that the modified endurance strength value is going to be 175.93 megapascal. Okay, so we can see here all the graphs and the table that we used earlier to calculate the value for the site factor, the reliability factor for our calculation. And we simply just multiply all the factors by each other, then multiply it by the endurance strength value to find the modified endurance strength value that we're going to use in the following steps of the design procedure.